Hey everyone, good to see you here. We're going to talk about learning how to code in R and talk over some of the basics. So we might have some people join in the chat. We'll get started here with the first thing to learn how to do. And that is going to be, what is R and what is RStudio? So let's mark this with a timestamp right here and talk over what is R and what is RStudio. So what is R and RStudio? So R itself is a language. And what do we mean by that? It's basically, there's different languages for coding like C++, C#, Java, JavaScript, which is not Java. You've got Python, another big language out there. And then you have what is called R. And RStudio is just a studio to do R inside of. There's other things you can do R inside of, like Jupyter Notebooks. Interestingly, RStudio can also do Python code. We'll go right here, and I'm going to open up a new RMD file. So let's go here to new R Markdown file. I'm going to blank my screen really quickly while I open this. And it is open now. And this is just under File, New Markdown file. And what this creates is what is called a Markdown file inside of R. So a Markdown file is different from a script, where a script is just R code. You notice right here, this has an R with a blue, and this has an R with an RMD. So the R script is pure code. Everything here is code, 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 and this is just where you do the R language. But the RMD file is a unique type of file inside of RStudio that allows you to make what is called a Markdown file. And a Markdown file can be turned into a Word document, a PDF, and you can also view it visually and edit with tools like this, where you can do bolding like in Microsoft Word. Now, the reason I don't always use Markdown files is because I'll usually go into Word just to fix up my files. So I'll make graphics inside of R, and I won't always use RMD files. But if you want to use an RMD file, you could do all your editing inside of here and then go to knit and make a website with an HTML, a PDF, or a Word file. So really, there's lots of options on how to make things. The two primary ones I use are either R scripts or R Markdown files. You can see there's a lot more options and many more things to talk about. And this is why I really like RStudio, because if you're just coding in R, you'll just be making R scripts. So an R script is just basically a bunch of code in R. Think of it as like a script for a movie where just everything happens when you run it. What do we mean by that? Well, if we have a bunch of things in an R script, all the code is going to run. We're just going to put some easy to know math right here to start. And when you run a script, everything in the script runs. So the script is just a set of instructions for code to do. But the RMD file differs than a script because you have what are called code chunks. So it's an important thing to know that an R script is the basic kind of R that anyone would use, even if they don't have RStudio. But an RMD file, the Markdown portion of it, allows you to do things like insert paragraphs. This is not code. This is actually kind of LaTeX, or kind of a way of making it do bolds or headings. As you see right here, the stars are going to make it bold when I go to the viewer. That's not really coding. That is a special kind of character call within the LaTeX language or way of doing scripts, which I really don't do a lot of LaTeX. So I misspoke right there. Don't listen to what I say on LaTeX. Listen to what I say on R, because that's what I do. Here you see an R chunk. So the R chunk right here is completely analogous to the R script. As in, inside of an R chunk, this is where you do all your R code. So you could put inside of here your 2 plus 2 and then run the chunk. We're going to run all chunks above, so every single chunk above this will run, and then we're going to run the current chunk. So what did this chunk do when I ran it? There's an object inside of base R, which means the R everybody has. If you download R, you have base R, the base package of R. And with this, there's a data set called cars, and cars has inside of it data on speed and distance of cars. Then next ran my 2 plus 2. So you can go to any sort of chunk, run all chunks above if you want to run the chunks above, or run current chunk to get the output from the current chunk, which is a plot of the pressure, which is another vector or set of information inside of base R right here. So as you notice, there's a lot of options, and the world expands very quickly. But the key things you need to know is that R is the language, and then RStudio is going to allow us to better interact using R. We have more windows here that we can use, such as the global environment showing us everything we have loaded into R, and then also the plot window to show us plots, and then the code evaluation down here at the bottom, And lastly, our files that we're currently looking into over in the top left corner. So that's what R in RStudio is, and you can clean it up rather quickly by clicking these dustpans to remove everything out. So now we're going down to kind of more of a basic what you would see if you don't have anything loaded into R. Well, for this next section, let's start talking over how to use R as a calculator. Now we've got the timestamp. So if you want to practice using R as a calculator, try going over here and going to the plus icon and go to R script. And maybe give yourself some simple tasks to do to have your memory pulled to see if you know how to do these tasks. I was going to say to remember, and then my memory went. So let's put in a task right here, add two numbers. You can make text bigger by hitting Control-Shift-Plus or Control-Plus, rather, on your keyboard, and now it's a little bit easier for you to read. Let's say subtract two numbers, multiply two numbers, and these are comments right here. A comment is not actually code. You can put it after any code and it won't be evaluated. So it can't mess up two numbers. Like if I said divide two numbers, notice even how the text changed when I wrote a T because it's registering that as true. That's a special character for true, but this is not a line of code and this won't run properly. So what we do rather is this is just a comment, and a comment is just kind of what you're telling people something does or the task we're going to complete. We'll add in a few other ones right here, like take the square root of something. Additionally, we could raise to a value. And let's say log 10 a value, already doing the code of it. And let's say find the remainder when divided by 5. Okay, so we've got 8 different tasks right here that we should be able to do mathematically because R can be used as a calculator and we can just run code and solve our math equations. So a lot of times I like to do math in R because it speeds things up. Let's take a look at add two numbers. Well, it's exactly what you would think it would be, 10 plus 5. Notice the comment can stay at the end of it, and you see the comment is in what happened, and it doesn't change anything about the code. It's just the code right here that is actually running. Subtract two numbers is going to run the same way, just like with multiply two numbers, the classic things that we learned growing up. I will say this, though, be very careful. You cannot multiply numbers the following way. And the reason is, it's going to be more in our next section, but it evaluates this as a function. 10 is a function now with the argument 5. And you see it says attempt to apply non-function. So this won't work. I did it so many times when coding in R. 10 times 5 should be 10 multiplied by 5, and that will work. Square root has a lot of different ways to run it. Probably my favorite is SQRT. And we could take the square root of 10, which is going to be like 3.2-ish, 3.2 rounded, and we now have the square root of 10. You could also do something as easy as taking 10 and raising it to the 1/2 power, but be careful. If you raise it to the 1/2 power like this, you'll get 5. Why did that occur? Well, what it sees inside of R is 10 raised to the 1, then divide by 2. So what I always tell students is, make sure to put things in parentheses if you want them to evaluate. So now that 1/2 evaluates and turns into 0.5, which we could have also just put there too, and now we get 10 to the 1/2 power. Raising something to the 1/2 power is equivalent to taking the square root in mathematics. So now we have raised to a value. It's going to be just what we did a moment ago. 10 raised to the 2nd power, just with a caret, and there we go right there. We now have 10 raised to the 2nd power. Log 10 a value. What do we mean by that? Log 10 means, what do you have to, let's see, log 10 of 100 is 2. So the question for log 10 is always, what would 10 need to be raised to get this value? Logs are kind of a weird thing to work with. They undo exponentials. So let's repeat that. The log 10 function allows us to take the log 10 of a value. So when you have 100 inside of this, the answer to the question is, what power does 10 need to be raised to get 100? And the answer is 2. And log 10s are kind of nice because you can basically just count the zeros and figure out if you have something odd like 3,000, well, it's going to be somewhere between 3 and 4, probably 3.2. It's 3.5. I went way too low on that one. But I knew it was between 3 and 4 because I know when I go up to 10,000, if you count the zeros, that is 4. And 1,000, the log 10 of it, is 3. So we can deduce that the log 10 of something like 3 or 4,000 has to be between those numbers. And there's the log 10 of 4,000 right there. So you can do all different things and figure these out rather quickly inside of R. But this one's a bit interesting. We have find the remainder when divided by 5. So we can kind of think this through and think what we'd get. Maybe we have 22 divided by 5. Well, 22 divided by 5 goes in equally 4 times, and then we would get 2 as a remainder. So we get 4.4 because it goes in, the 2's a remainder, 2/5 is 0.4. But is there a quicker way to do it and not have to figure this out? Yeah, 22, and you have to do what's called modulo 5. And this actually just finds the remainder of it. So you'll notice here, if I put this to something like 34, what's the remainder? It'll be 4. And this can tell you if there's kind of an overage if something doesn't go in equally. We actually use this for a lot of our equations sometimes to see if something is not equally going in, and we can write it rather quickly. Maybe we have a big number here like this, and then we say, is that divisible by 3? What we could do is we could do a logical check. And let's do logical next. We'd say, is it equal to 0? And the answer is false. So probably if I go up to the next odd number, or we could just check right here, and we should get one. There it is. There's true. I think there's neat things you can do to figure out if things are divisible by 3, but this means the remainder is equal to 0. So that's how we can find remainders right there. Now we'll add one last addendum to this math part. If you don't want to do a log 10, which is just more of a classic log, you can use the log function. The log function takes two things. What do you want to take the log of, and what do you want the base of? If you don't enter in a base, 2.7182818284590452353. There we go. And that is because the base is e. So without anything entered in, you get a base equal to e, and e can be called with the exponential function. So this is e right here, and you can call e or memorize it. But now we have what do you have to raise e to get 9? And you have to raise it to 2.2 basically. But you can change the base here to what do you have to raise 3 to get 9? So what's the answer? What do you have to raise 3 to get 9? Because that's log 9 of base 3. And the answer is 2. So thinking through this, understanding how these functions work, and knowing what you should get before you click enter, like changing this to 27, we should get 3, because to get 27, you would have to raise 3 to the third power. Just doing this right here and practicing and understanding the mathematics behind it and how to run these functions. So that is how to use R as a calculator, basics. So this is how to use R as a calculator. I might even post this little help file right here. Next, let's go down here and talk about logical functions. We kind of broached that topic right there and talked about logical functions, but let's go in depth on it. So a logical function returns what is called a Boolean. A Boolean is a true or a false, a binary operator, and it can go by many names. The three we have inside of R really are going to be true. Let's write them out in a vector. True, true, and also 1 is true. Notice they're all 1s. It's because I have a numeric value in the vector. So it forced the vector, which is just a row of data. It's just all the data is put in order, and we use this C function to concatenate it or paste it together. Not quite paste, but put everything together into 3 little bins of information. Position 1, position 2, position 3. We can make a false vector 2 right here, and the false can be either lowercase f, capital false, and do notice as I type the f, it's blue, and not until I get to the very end is it blue. You can't type the lowercase, it will use the autocorrect to fix it, but then also 0. Everything in this is the same, whether it's capital T, capital true, or 1, or whether it's capital F, capital false, or 0. They all evaluate the same to true or false. And this can be used a lot of ways. So maybe our friend gave us a bunch of numbers here. So these are just a bunch of numbers. We want to see if any of these numbers are even. So now we have to think back to our arithmetic. What does it mean if these numbers are even? Well, I think we kind of know it. So you could answer this without looking at it. You could be like, let's see, even, even, even. Well, from what we know about mathematics, a number is even when 2 evenly goes into it, or goes into it without remainder. So if we can divide it by 2, wait a minute, modulo. So dividing it by 2, we can see the remainder. And what's really cool about this is we get a vector of the remainder. Notice here, it's a remainder of 1, 1, 1, 0, because it went in evenly, 1, 0, and 0. So that's not logical, right? We can make it logical. We can take the same information we had, and if you highlight it, you can then go around it and hit Shift 9 to put it inside of parentheses. Now, this is a logical check right here called logical equals. Logical equals will see if whatever's over there on the left is exactly the same on the right. And it's going to do it for each thing on the left. It's going to check the first one, then the second one, then the third one, and it's going to go through and see if it's equal to 0. Remember, we just found the remainder on the previous line, so there you go. So now we have if it is equal to 0. So we now know the numbers that are have a remainder of 0 and are thus equal inside of this vector to 0 in the remainder and are even. So what else can we do with this? Well, with this information right here, we could actually find the positions of them. So this is, let's write next to it, checking if something is equal. That is where we can check if something is equal. We're not using the plot window right now, so we'll just do that. How about finding positions of the equals? Finding positions of the trues. So we want to find positions where they're at. Well, let's do this. Let's store this as x. Now this left arrow you're seeing me do creates the object x here in the global environment. And x is going to be filled with the remainders. Take a look over here, you can see the false, filled with the logical check we just did. False, 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 true, true. And what about this now? Let's find the positions of the trues. To find the positions of the trues, we can put it inside of a which function. Now, we have to know what each function does when we call it, because the which function is just going to tell you where the trues are at. I like to think of it as which ones are true. And so we have to think, what's the output of this going to be? Well, the output's going to be 4, 6, 7. Why? Because position 1 is false, position 2 is false, 3, 4, 4 is true, and 6 and 7 are true. So when you run which, you get the positions of the trues. Which ones are true? Position 4 is true, position 6 is true, position 7 is true. So how can we use this? I like to store this as positions. If you now go to your original vector right here, you can actually call the positions. To call just those positions, we need to look at one more thing, which is position brackets. Position brackets can be called by using square brackets, and there'll be a lot of review. But notice we put the positions right there, and there's the true values, because I'm only getting the values inside of positions 4, 6, and 7. You can do a lot with logicals. Let's look at a few more use cases of logicals. So what are you trying to learn right now? Just how to use logicals, right? So let's try something. What if we have, let's say, more numbers? Numbers right here, and they go from 1 to 1,000. So that creates the vector of numbers 1 through 1,000. How about if we want to figure out how many numbers are greater than or equal to 600? I know we can do that, but sometimes you get a little bit worried. You're like, is it 400 or do I need to keep the extra one? Is it 401? 400, right? Let's double check our math. So what we would do right here is we would take the numbers that we've created and say, are they greater than or equal to 600? Now what this is going to do is it's going to return trues and falses. And look at where the trues begin. The trues begin right here. Notice those position brackets we just talked about? This is telling you inside of the numbers vector, position 593 is false. Position 601 is true, and right before that would be position 600, which is greater than or equal to the value of 600. Hence, the trues begin there at position 600. So now, how would we figure out how many? Remember how I said trues and falses are just ones and zeros? Well, let's store this logical vector over x. Now, this is overwriting it and replacing what we put into x. So now x is going to be the logical check. Let's make sure it's stored properly. There it is. X is going to be the logical check. You can see it up here in the brain of all these trues and falses we just made. Well, if they're ones and zeros, can't we just add them up? Yeah, we can. So just take the sum of X, and it's 401. I was right. Because you got that extra one right there when you go from 601. It's like comparing to 601 to 1,000 is basic 400. And the 600 is the extra one, or kind of the, I guess 1,000 is technically the extra one. But when you think about it, 1, 2, 3, 4, 5, 6, 7, 8, 9 to 100 is 100 numbers. If you add in the 0, you've added in 101 numbers if you put it on the other side of it. So notice how we were able to do a greater than or equal to test right here. There's a lot more we can do, though. So how about something interesting here? What about if we have a logical check where we have these numbers right here and they're secret numbers? So watch this. We're going to have secret numbers right here. And the secret numbers, okay, they are secret numbers and you can't see them all. So now we got these secret numbers. Well, you can see them down at the bottom of the screen. So there's these secret numbers that you have to investigate. And with these numbers, you want to see if 12 is inside of there. Now, to see this, what would we have to do? We can run a really quick check. Good to see you there, Snowkeys. And we're going to do some check right here to see if 12 is contained in that vector. So is 12 in the vector? The line of data right there. Well, we write this out. 12, is it contained in, that's %in%, the secret vector? And guess what? The answer is true. You say, Brian, wait a minute. Didn't we just do equals equals? We can do equals equals. But what equals equals is going to do different is it's going to check each position. So we're going to get a much longer vector of false, 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 true. And there it is right there. So they accomplish different tasks. Is 12 contained in this vector? Yes, it is. Are the positions in the vector equal to 12? No, 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 yes. You can also do something like, is 3 contained in the vector or 12 by saying, are they contained inside the secret vector? And the answer is 3 is not contained inside the vector and 12 is contained inside the vector. And you think about, why does this matter? Why do we need to know the secret numbers if they're contained in the vector? Well, there's so many ways to use this with coding. Maybe you're trying to look up to see if someone attended an event. So is this name in the attendance sheet? That's the code that will be running in the background. We don't need the full vector of they're not this person, they're not this person, they're not this person, they are this person. We just want one return on the code of, yes, that person attended the event. It is true that they are contained in the vector of attendees. So you have to think about how these would be used on bigger examples, because right now we're just talking about how to do the coding, and then applying it is what matters. So let's actually break into talking about functions. Good to see you, VD. This is what is called R in our studio. And if you have questions, feel free to ask. I'm honored some people are swinging by. We've got, yep, so I'm watching the chat. VD and Snowkey, is good to see you there. We're going to talk about functions in R. So you can hear a little bit about functions in R and how they work. And you can maybe mention some C+ in the chat if you want. So what is a function? I like to think of a function as a set of instructions on how to do something. My best example, if I had a function called make dinner, it would look like the following. Of course, it'd be pizza, and then it would be 7, and we could say here something like PM, and then we could say soda. It's Friday night. Come on. Pizza and soda, classic. So what is this? It's a set of instructions on how the make dinner function will work. Unfortunately, I can't just run a function to make dinner, but the arguments, which is what these are, this is argument 1 and argument 2. So R has what are called functions, and it's probably very different from C+, which I've barely done any of. So the function takes place inside of the parentheses right here. Does that make sense? The function itself has a name like the make dinner function. And then the arguments are the set of instructions inside the function. Now, I don't have a make dinner function. There's no function called make dinner. But I do have other functions, like finding the mean. So remember that secret vector we had? Well, if I go to the mean of secret vector, there's the mean of the secret vector. So what is the first thing inside the mean function? Well, it's what do you want to take the mean of? If you're confused on what functions do, you can always add a question mark and run it, and then you will get the instructions for how the function works. Notice each of the arguments are separated by a comma, and you also get instructions for what each of the arguments does. So the first thing inside of this that we use is called x. So what are we taking the mean of? That's what x is. That's the thing, the object we will take the mean of. The next thing is trim. Trim is something I don't do very much, but when you trim a vector, it takes off, when you put it in order, you take off values on both sides of it. So you're trimming down often outliers or extreme values. So this is called a trimmed mean, and people might take off 5, 10, 15% to trim off extreme outliers, which can highly impact the mean. And that's more of a statistics topic than a kind of how to code topic. NA remove equals false stands for do not remove the missingness. And what is missingness? Another topic to bring up. It's when you have a capital NA, which is a special character for missing values. Now notice it's capital N, capital A, and that stands for missingness. So what's in position 3? The answer is nothing. You have to be very careful though, because if you were to put this in quotes, it would change the vector to a character vector. So it forces the class character because capital NA in quotes is a word. You have to be also careful because if you do NA with like lowercase, then that is the object NA. And you can see by the color coding on the screen that this is not the special character color blue. And it will tell you it cannot find the object NA because it does not exist in the global environment, which is the brain of R. So a few things you might have heard is that each vector has a class or a type of object it is. Putting this back to the value 5 will make it a numeric class. So now when you run it, it is numeric. Or we'll go down here and write class of the secret vector, and you can see it's a numeric vector. Putting the 5 inside of quotes will switch it to a character class, often known as strings in other languages. Viti, tell me if these make sense for you. But these sorts of class of objects tell R how it's going to handle this or run it through certain functions or codes. So some functions like a mean function are going to require that it's numeric or logical. And if this were to be a logical vector, we already have a few of those earlier on. We made a logical vector right here. Let's change this to true also. And now this is a logical vector. So if I store this inside of logica or logical, and we run a class on it, have a question. Let's see what the question is. Logical. The logical vector has logical class, if we did class right. I have a question. Sorry for interrupting you. What are offers that Python cannot? So really good question. No, Snowkeys, I wish I could throw you points right here. But R is a little bit sometimes considered more academic, and Python sometimes considered more industry-esque. They each have what are called different packages or libraries, like pandas inside of Python and ggplot2 inside of R. It's kind of a, would you rather have vanilla or strawberry or chocolate ice cream? Everyone's going to have a different preference, and there might be better times for certain flavors of ice cream. But at this point, R and Python are pretty similar, but certain companies might have certain preferences and say, hey, we code in Python here. What's really great with AI is if you have some code in R, you can usually say, write the equivalent code in Python, and it'll be done. The best coders are going to know quite a few languages, and I'm not the best coder because I really only know one really well. I know I've done some Python, some HTML, very little others. So the best coders are often going to know many languages. And please ask more questions if you got them. This is a live stream, so you're free to drop in questions. You could ask how to do something. You could expand. And we're just talking about functions right now. So anything you got, and especially if it's coding, I'm honored to answer it. We appreciate all people here. Stats1 UK, you're welcome. It's awesome. Where are you both? If you want to say where you're from, like in general, whether it's United States or Europe or Australia or wherever you're from, you're free to say that if you want. It's your call, but we've had many guests from all over the world even here. So honored to have you. So a function is going to let us run a bunch of instructions that do something. So the mean function has 3 things inside of it. But you say, Brian, you only put in one of those. It's because the other arguments have what are called defaults. If I don't tell it how much to trim, it'll trim nothing. If I don't tell it if I want to remove things, it'll say false. Saudi Arabia, awesome. Data analytics intern at a company, cool. Oh man, it makes my day that we have people from all over the world. Well, keep it up, keep asking those data analytics questions, and we're honored to have you here. So how about another function? Here's a classic one we use, especially in data analytics. And this is a function called LM. I can't even speak today. LM stands for linear model. So the linear model function takes the following. It's going to take y tilde x, the formula, look, it shows right above. The formula is y tilde x. That's a special type of thing. Tilde is over here on your keyboard next to 1. It's that button right there with the dash next to 1, a little tilde. And that is a formula format for like y equals x, basically. And then we do another argument a lot of times and say data equals. You can write more, you can do subsets, you can do weights and NA action and method and all these other things. But as The Rock would say, it doesn't matter. We don't need them right now. So let's start working with some data and see how we can use this LM function. Well, there's a data set inside of R, and this is a function to call data. So this function brings data to us, data that's inside of R already. And so this function empty or data empty cars is going to load the empty cars data set. And apparently I might have also clicked it because you can now see the data inside of it. And it looks like an Excel spreadsheet. So I'm going to go right here and put the data right there. Now, when you load it, it actually doesn't have to be in quotes. I think because I put it in quotes, it showed it. I don't usually do that. When you do data equals, it's not going to have quotes for this function. It can be tricky sometimes to know which things have to go in quotes and which things don't. Mistakes can happen. I've also been tasked with analyzing some data and creating some dashboards, but I realized that the things I'm supposed to do cannot be done due to the one who made the database has many incompletes, much missingness. That's a common issue. I could maybe give you some thoughts or advice on that, Snowkeys. And yeah, so actually, you know what? Let's make the next section of this cleaning data. Since you're here, I'll talk this next section about cleaning data right after functions, like working with messy data and cleaning data. So we'll talk about that next. Thank you. So let's look at the MT cars data frame. Now, one thing to notice about data frames here is that inside of a data frame are vectors. And what do we mean by vectors? Well, cool, you can see them right there. It's the same thing we made earlier with the C. But each one of these vectors is just a line of data. It looks like an Excel spreadsheet. And you can get to the vectors by doing the $sign. Now, we don't have to do that here because it knows we're looking for empty cars. But with empty cars for MotorTrend cars, yeah, you're welcome. I like working with data. I like students. I like data. That's what I like. We're predicting the Y variable of interest is miles per gallon, and the X variable is horsepower, and we've made the linear model. So this function reads the following way. Argument 1 is the formula, predict miles per gallon using horsepower as the explanatory. Argument 2 is from the data set, empty cars. And then we're going to go in front of it and call model M, which doesn't exist, and left arrow into it. So left arrow means store into, create this object. So that's going to store into, create the object M, which is the linear model from the formula miles per gallon equals horsepower in some sort of y equals mx plus b. And then the data is from the empty cars data set, which you can see over here. We've now created the object M. And what's really great about this is we have so many functions we can run right now, like a summary of the object M. We can visualize the object M. We'll make this bigger here because we're going to visualize the object M with visualize model. All of these are inside of the reg class library. So if you have reg class, run it. Or if you don't, install reg class, install.packages, reg class, and that will install the regression package library. I already had it pulled up from earlier. And we can do so many things right here, like a check regression to see if we are doing regression properly. And these are all little functions that only take the object M here to see if we are doing it properly. One of my favorites is the choose order function, and you can even type things out of order. I want to show that again because it kind of smartly looks through. Notice I don't have everything correctly right there, but as long as the letters go in order, it will find the function. So typos can be fixed by clicking autocomplete. And then we can look at a choose order to look for non-linearity issues. Make the plot a little bit smaller, and you can see maybe a second order polynomial would be better than the first order. And And these are topics we teach in data analytics on how to examine linearity versus nonlinearity. We could add in one more argument, which is another set of instructions to say, only show me max order 2. And now it's a little more apparent that this has a second order polynomial fit. So this is kind of the goal of data analytics, is to do descriptive or predictive analytics, and then to make these decisions on what is better. And we have metrics like R squared. So once again, to review on functions, a function just does instructions for us. So when you see this choose order function, the choose order function is going to help me choose the polynomial order for a model. And I have to give it my model, and then I can also tell it the max order. I like to put these on separate lines because it's a little easier to read. So now let's talk about cleaning messy data. Oh, fun stuff. And feel free to, so Snookies, feel free to put in your thoughts or tell me how this applies to you. Cleaning messy data. And the reason I was so excited that you said this is because a lot of times in academic work, we give people nice, clean, easy to work with data. Like it's just perfect. Like this data set right here, no missingness, no problems. But data, and I'm actually going to go to AI and ask it this question. I'm going to say, are there any base data sets in R that are messy? And so let's see, are there any base data sets in R that are messy and have missing data? If not, give me a package that has messy data to practice cleaning. I actually do have one I know of off the top of my head. And there's a missing pattern package to use, and I need to use that also. Oh, air quality has messy data, they're saying? Okay, let's take a look. And let's say, what package in R can help me deal with missingness and give me functions I should use from it? Okay, so, and then they're also telling an NC flight data set. Okay, so here we go. Empty cars, no, that's not messy. Okay. So dealing with messy data. Once again, we have to know what missingness means. And let's see if the air quality data set has missingness. Okay, so this is a data set we're looking at, air quality. Yep. All right, there. Ooh, look at that vector, the ozone vector. I see it. Missingness is going to appear as NAs inside of here. That's missingness. This one's a little messy. So I need to create a funnel that shows the person who requested the product until contract applied. There is, for example, some tables I need to examine, like credit assessment table, but for this table. So you need to create a funnel. I'm trying to think what you mean by a funnel. That shows the person who requested the product. So I think you're merging. Are you using like SQL and merging data frames? Does that sound right, Snowkeys? You've got like the person who requested, but then you have another data frame, and then it connects in and pulls that in and then merges and returns back a data frame of information or a subset of that data. Does that sound accurate? We could try to replicate that. It sounds to me like there's basically a request, or if it's a singular thing, then you're looking at like subsetting, or if it's from different. The table for credit only has data from September. Oof. Oh man, I wish I could see a lot of data. So here we go. We'll take a look at this. And it has missingness, does it? It has missingness. The table for credit only has the data from the 26 September only. If it's only like one thing, you might not have certain customers. That's going to sound hard. So if you just have a lack of data, that's another issue, because then you might not even have the data to figure out what's going on. I think I need to talk to the data engineer who made it bad. Yeah. Now we're talking about the data pipeline. Snookies, I like what you're doing. And this is what we have a lot of times in data is if you have junk data, you have junk results. So the data pipeline of how the data is collected, how the data is put in, how the data is stored, and then how the data is pulled. You think about somewhere along that chain of events, the data can get disrupted or improperly organized, and then you can't get the proper insights from data. So it sounds like to me, your data is not at the point where the decisions can be made from it. And with that, the process needs to be looked at by which we can have the data stored to which we can make the decisions. Yeah, it's tough. Well, congratulations on the internship. and you're dealing with the real world problems. You are dealing with exactly what people have to deal with when it comes to data. So, and I appreciate you so much being here. This brightens my day. I like talking about data. It's fun. It's fun. I mean, it's a headache, right? But yep. So that's literally, you're hearing it right now. These are the real discussions that we need to make sure the data is being stored. We got what we need. It doesn't have the missingness. It is validated. And so you can see right here at the data air quality, this is messy data. We can do a function, a logical function to review logicals called is.na, and we can do it on the air quality data set. Now what this is going to do is it's going to tell us for everything whether it's missing. I want an advice, what exactly, here's what I would say, and this is my best advice. Speak to the person over your internship, ask them their thought, tell them what you think, and get their advice on how to move forward. Like speak to the people in your department first, so go to the people nearest to you always, and get their advice. Say, here's what I'm seeing, here's what I'm thinking. How do you think we should proceed forward? And maybe you could even give them some ideas and be like, I was thinking I could try to analyze the data more, or I could go to the engineers. If you give people two options a lot of times, it sounds better because then that gives them some autonomy to make a choice. And if they say, yeah, we should go talk to the engineers, then you have buy-in from people. So it comes down to the psychology of this, that when you're in business, which we teach business analytics here, you want to have people on board on your decisions. So making sure you go through proper chains of command, that especially being an intern, which sounds like you got something good right here. It sounds like you got things that need to be talked about. And then, making sure you have the rapport and the kind of relationship with people to then bring that information. And then they say, you're right, we should be looking into that. So I think go through the proper chains of command to bring to the attention your thoughts that you're having. Get buy-in from the chain of command to say, they could say, no, don't talk to the engineers. Like it could stop at that. So you think of it as a process. So proper chain of command, get buy-in, talk to engineers, clean up data, get insights, profit. Does that make sense, Snowkeys? I'll repeat it again. Proper chain of command, get buy-in, talk to engineers with buy-in and proper chain of command, get better data, profit. There we go. That's the line for profit right there. I love the real world application. It's the psychology too. Yeah. I appreciate that. It's very kind of you. No, we have a MuBot here too. We're having a little bit of fun at this little midsection right here. Right, MuBot, you want up here?
I am the real brain behind 201, but I am currently broken. Thank you, Snowkeys.
He takes all the credit from me. He helps teach. You can see some of our other live streams, and you're always welcome to swing by when you see us live. You'll oftentimes see me doing Stat 201 stuff, teaching t-tests, chi-squared, all that fun stuff we do in 201. And we're doing a special stream right now with different sections. I'll label this section, I'll label it dealing with real world analytics and real world problems. And you're always welcome to come in. And if I especially have time right now, because it's just a Friday stream, and I was like, let's do some stuff. Let's. Students had asked for more coding experience. Hey, Poke, good to see you there. So we'll say real world analytics problems. And so we'll call this real world analytics problems for this section. So what I do is I put timestamps in these videos so that anyone could come back later and rewatch the video. And if they're rewatching it, they can get insight from it. Never heard of R? Let's talk a little more about it. So how about for this next section, let's talk about what are packages inside of R. We've alluded to these things here. What are packages? So we're going to go back to our script that we've been writing out right here, and we'll say, what are packages? Packages are probably one of the best things we have. It's basically someone wrote a whole bunch of code or created a whole bunch of things and put them in a nice, neat little package for you and said, here's my gift to you. And a lot of the packages I use are things like reg class, which stands for regression class. And you get to see a little bit about what it is. Contains basic tools for visualizing, interpreting, and building regression models. And when you run this, it starts up the package, and you can also see it's now running in the background here. These are all the packages. Well, if they have a check, I currently have it running, and you can see that reg class is running right down, I don't know my alphabet, right down there. So reg class is currently running. You can also click one of these right here, like readr, and it'll run it. To start a package, you simply click it, or preferably a lot of times you write the code library and you put the name of the package. Now, you can't run a package if you don't have it installed. Like, do I have cowsay? One of my favorite little packages. No, I have cowplot, but not cowsay. So cowsay does not exist. But if I want to install a package, so it's going to get me cool, fun, new stuff right here. I go install.packages, and then it has to be in quotes because it's going to look for the name of this package on the CRAN server, which is where everything R is located, and it is now downloaded cowsay. There's other places for R on the internet, but a lot of the cool stuff's on CRAN. And so now we're going to load the library with library and then cowsay. And cowsay, which I don't have the latest version of R, if I remember correctly, this is how you look at functions inside the package, uses the function say. So let's go say, and with say, we're going to say, great job class, say great job class, and then we'll say ba equals cat. There we go. And that took 2 arguments. So you have argument 1, what is it going to say? And 2, what's it going to be by? So this is not a majorly important package, but it gives me the ability to make ASCII art, this little fun art stuff here, where we can just have certain animals saying certain things. You can also check out the function by clicking question mark and then the name of the function, and you can see the different names of the animals. Like, let's go over here to a pumpkin. So now we can switch it up by going right here and changing this to pumpkin, and there you go right there. Great job, class. Long cat, it's a long cat, I'll tell you that much. So we go right here, and I'm clicking up to make the code reappear in the bottom console. And now, oh, error in your windows. You can't use, oh, is my Windows too small? I think it's too small. I can't use those? Well, that's too sad. Well, apparently there is no long cat for us today. There is not, but we can get a squirrel. There's a squirrel. Great job, class. So once again, packages basically give you a whole bunch of great things. Other packages I really, really like, and these are some cool ones you're about to see, are going to be things like ggally. And I don't know why it's called ggally. I'm going to find out right here by typing in ggally. Oh, do I not? I have ggpubr on here, I believe. I don't have ggpubr or ggally. I do have ggpubr. I don't know why it didn't autocomplete. Let's see if I have ggally. There we go, ggally. ggally is a plotting system based on the grammar of graphics. ggally extends ggplot2 by adding several functions to reduce the complexity. That's right there. And ggally, I'm looking inside the package by doing the : Let me go ggally again. Packages equals tools. Yeah, pretty much. That's a really great way of thinking about it. This is everything inside of it. So this lets me view inside the package right here by doing the : So this says, go to that package and look inside it. As in, here's the package I want to look inside. And when you do the : you're getting a view inside of everything inside here. There's fleas, apparently. Yeah, that contains the physical measurements of 3 species of flea beetles. So there you go right here. There is the measurements of the flea beetles. I didn't know I wanted that, but now I have it. Yeah, you're welcome. Anytime. Keep asking questions, and I'll keep trying to explain. There's a really good function I like. I'm trying to remember it. I think it's ggarrange. Ggarrange. It is. Oh, it's in ggpubr. So ggarrange, and I want to show you how I knew that was inside of ggpubr. If you type the function, you can see down here what package it's inside of. So they show you it's inside of the ggpubr function. And I think ggarrange is the one I want. I'm going to try the mtcars data set inside of it, and it's mad at me. So let me chat GPT again, and remember, I believe there is a function in ggally that makes a ggplot of all the variables. What is it? Okay. So I'm looking for a function that I've forgotten for the moment, and it's ggpairs, that does all the graphics for me instantaneously. So this is going to do a visualization of every vector inside of empty cars, and it's a little bit much. We could do a smaller data set here, like the iris data set, and now we get a visualization of all the different information inside the iris data set. Iris dataset is another base dataset inside of R, and you can see here a histogram or kind of a density plot of data to where you can see slight bimodality, unimodality, little bit of uniform at the top, but still unimodal. You can see interesting patterns within here and the correlations between two quantitative variables and the side-by-side box plots and the bar chart to show you the species right there. This is a little bit too much information on one screen for someone who's not doing data analytics. It's a good investigatory, good graphic to investigate what's going on. Let's put it that way. And once again, it's hard to remember every single function. You'll get to use certain functions over and over again and start to develop favorite packages. Put it this way, if I had to write the code that ggpairs does, how much code would I have to write? Well, ggpairs is doing a visualization pairwise of every single vector inside the iris data frame. If I go down here and run ggpairs without the parentheses, it will give me the full code inside of ggpairs. So here is the code inside of ggpairs. And I would have to write, if I were to do this by hand, 78 lines of code. You know what would be interesting? Let's say this. Make this a much cooler, better function. Going over to AI, which I love using AI, I've asked AI to make the ggpairs function. Here's an improved version of ggpairs. It knew it was ggpairs. So now it's giving me an improved version of ggpairs. And so this is the beauty of AI, is that you can ask it to do things for you, like improve functions that you already have. And so they've made this function for us, but let's see if this actually looks better. I don't know what the people who've made ggpairs are going to think. I see with this bit of info, I maybe can make some assumptions that R can handle big data. Yes, it can handle big data. And a lot of times there's packages you would use for that. So R can handle big data. And now we have our new cool function, cooler ggpairs. Here is our cooler ggpairs, and it looks like maybe they gave me could not find function, warning arguments exist. Okay, so we're going to remove this. Check for deprecated arguments. No, we're going to remove that out. Could not find function, fixed data. Well, so much for our cooler function. It doesn't work. We're going to remove out that. Could not find function, fix. Last try here. Come on, ChatGPT. What are you doing to me? So, ChatGPT is not happy today. Oh, here we go. Took multiple attempts to get it to work. And here's our cooler ggplots. I really don't see that. Oh, it added lines. We got new lines on it, it looks like. Oh, it added linear models. And it looks like it added another row of data. I don't know if I like it better, but it did add a linear model to each of the correlation plots I notice. And I don't notice much else different, but maybe it's cooler. You never know. But we do have a linear model added to the correlation plots. So pretty neat. You could compare this to the ggpairs, and it could just be the extra arguments we've added in also, because I don't know all the arguments or extra commas you can add. So there's the original ggpairs and there's the cooler ggpairs. But in truth, we could try this over here. We could just take and call this ggpairs to see if the function works with those arguments. And it looks like it does. So I don't know if our cooler function is actually cooler. And so rather than write all these functions yourself, the main theme of this section of the video right now is libraries are going to help you get the things you want. If I want to make a cow say something or a cat say something, cow say, cat say. Well, it's cat say, but it's from the cow say package. If I want to analyze a regression model, well, I can use reg class after I've made my regression model to visualize the model very quickly. And so that's a function. If you look, visualize model is found inside the reg class package. One last thing to say right here is, why don't we just load every single package up, every single library up? all of these things take up memory, and you have functions can have the same names, and you don't want to use two functions in your environment if they have the same names. It's going to cause masking where functions have the same name, and it's going to cause confusion. So we don't want functions to have the same name. That's why we don't always load up all of our libraries at the same time. Let's see. What else to talk about? Maybe we should do one more topic, and thank you everyone who's here. Let's say 1, 2, 3, 4, 5, 6, 7 things you should know in R. 7 things you should know in R. If you have questions, let me know. What's the last thing you should know? Let's say creating things. There's so many things to know, but how do you create things? Well, it really comes down to the store function. And you've seen me maybe do this today, but it's this left arrow, which is the same thing as equals. N can be used alternatively with right arrows. So you've probably seen me do quite a few of these today, but this is just basically assign to. Now, I'm not the biggest fan of the equals because you use it in arguments for like m, lm, and then y till x, comma, data equals. And it's going to get really mad at me because all of these are going to be seen as code, but they won't properly evaluate yet. So this is not, it is kind of storing or assigning data to be equal to something, but it doesn't go into your global environment. It's kind of in a function world, a subworld of your world, a miniverse, a teenyverse. And with this right here, this is what gets stored into the global environment. Alternatively, this code could be written such that you say m is equal to, and then if you really want to do things crazy, you could say right arrow and do m. So all of these create the object m. They won't run right now because there's no y and x in my global environment to pull from, and data argument is blank. But what about if we say b save into 5? Well, now we're back to the beginning because what is b plus b? B plus b is 10. Because b is 5. Notice how we can assign the numeric value of 5 into the object b. And that's the wording we use. That's the object b with the numeric value 5, and then we're just doing math on it. So what if we say, let's say, you can't use t. Let's go here with e. So e is going to be 2. Now what is b raised to the 1 over e? Well, that's going to be a harder question. It's going to be 2.26. Oh, I should have just said 2.2. Would have looked more intelligent. Well, what is that? That's just 5 raised to the 1/2 power, square root of 5. And of course, again, you can use a function which takes the square root of something, something being x, and you get the same value. Notice how we're kind of going back and talking about some of the same ideas because things have a lot of overlap when you're doing coding. The function square root of 5 does the same thing as the mathematical operation of 5 raised to the value of 1/2. We could have stored into b 5 and stored into e 2. If you want to go one step further, why not just go to p and store that in 1 into it? And now you've got no numbers, but you have objects for all the numbers. So you can see that we can create things. Why would you do this? Why would you create something? Well, we did it earlier because maybe I'm trying to figure out from a data set inside of Survey 10. So this is a data set inside of reg class. Make sure you have reg class loaded or else you won't get to see Survey 10. And when you click this, it auto-completes and you now have in your global environment Survey 10. So Survey 10 exists right here. So with Survey 10 loaded into the global environment, let's look at the weights of individuals. Notice we did the $sign to find their weights, which is going to pull the vector, which is numeric, meaning a number, for the values. Here's all the weights of people. That's just a graphical error. Don't worry about it. We can see every single weight of everybody very quickly. So now, what if we want to figure out who weighs more than Brian? Brian weighs 185 pounds. Greater than or equal to 185. We did say more than, so let's go greater than. There's everyone who weighs more than me. Well, how about we take this and store it into the object check? Sometimes I call it check or something because I want to check it. I want to do more checks with it. So now the object check in the global environment is a logical vector of trues and falses for the 699 positions. Can something like this be legal? B store into A with A already being set to IDK any value? Totally. Yeah. So B store into E, and now take a look at what's going to happen right here. Really good question. What the characters are saying. So these are objects now. Good question. So this is the object B and the object E. So store the object E into the object B. So what's going to be stored into B? B will now become what? Think what's going to happen up there. So can you tell me in the chat when I say, yeah, so what will happen when I run this? The best thing to know about code is to know what's going to happen before you run it, because then you know the code. So what's going to happen when I run this? I didn't put the check mark for storing objects. We'll have to check this. What will happen? Well, we're going to store E into B. So B will become E and E is 2. So if B becomes E and E is 2, B becomes 2. Did you see it? Let's show it again right here and just watch that value. I'll have to reset B up here. And if we go down here and run this, you can see B is 5 currently and E is 2. So when 2, which is E, is stored into B, there we go. So we actually overwrote what was in B. Does that make sense right there, Poke? So that's kind of what we're doing is we're just overwriting, what is contained inside of B with what is contained inside of E. And we can store these long things right here, a long logical check of trues and falses, because this whole vector of trues and falses are stored here. And then we can do logical checks on it to find out how many individuals weigh more than Brian, what percent of individuals weigh more than Brian, which individuals in which positions weigh more than Brian. And then also what's really great, if we store this as positions, because that's the positions of the individuals, we can go to the survey weight vector and pull the positions and find the weights of the people. So all of this right here can be done, and you have to think about it like you're talking. So check for me if someone's weight is greater than 185. Store it into the object check. We'll make that a comment. Next, sum up the ones and zeros. Remember, trues and falses are ones and zeros. So this just says there's 114 trues. 114 things meet the condition. Find for me the average. Well, when it comes to average of ones and zeros, that's a percent of individuals that are true. 16.3%. You could even check this by timesing it by 699. So do some quick math in your head, 114. That's because it's 16% of 699, and multiplying by 699 would just undo the percentage of how many individuals there are out of 699. Next, we said store the individual's positions into something called position. And this is just the positions of the true. The third person weighs more than me. The seventh person weighs more than me. The ninth person weighs more than me. Now go to the vector inside of the data frame and pull the positions, which is going to pull the values in the positions. So there's many, many, many things you can do. And that's what's really great about coding is because just thinking about it, it's like, well, I want to store this. I want to create this. I want to check this. I want to create this graphic. And there's so many things you can do, but these are kind of 7 key things we talked about here. I think it's 1, 2, 3, 4, 5, 6, 7 key things you need to know about coding or should know. And Poke and Snowkeys and other, I think we had one more, Misfell right there. Good to see everyone here. Until then, we're going to play a fun outro. I think we have, which outro do we have going? Here we go. We'll do a fun outro. Bye for now, everyone. Bye.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!